All right, everybody. Okay, let's do the next example, number 3. It says, use the intermediate value theorem to show that f of x equals x cubed plus 2x minus 1 has a 0 within the interval of 0 and 1. Okay, so let's take a look at this. Here, let's look at the 3 conditions. Condition 1, is f of x continuous? Okay, that's what you always have to ask yourself. And the answer is yes. Why? Because all polynomials are continuous. Okay, let's look at the next one. Here, now we need to check f of a does not equal f of b. Okay, well here, what is our a? Remember, if I have the interval from 0 to 1, this is our a over here, and this is our b over here. And let's plug it in. What do you check to see if this works on your own? Okay, so let's see. So this is f of 0 is equal to 0 cubed plus 2 times 0 minus 1, and f of 1 is equal to 1 cubed plus 2 times 1 minus 1. And what is this equal to? Minus 1. And what is this equal to? 2. So we know that f of 0 is minus 1, and we know that f of 1 is 2. Thus, f of 0 does not equal f of 1. So this checks. This checks, right? They don't equal each other, and that's what you wanted to check. Condition 3. Let's see. Now here, when we have a 0 over here, since f of 0 is less than 0 and f of 1 is greater than 0, there exists a value of c where f of c equals 0 by IVT. Okay, and that's how we do this. We haven't, I actually just realized I didn't really show you this today, but the idea is it kind of comes from the, like visually, let me get something real quick. Where is it? Over here. Okay. Like visually, let's see, visually what is happening here? Visually. Notice, where is this point f of 0 equals minus 1? Okay, so where is this point over here? This point is 0, negative 1. So 0, negative 1 is here. That's one of the points. Where is this point? 1, 2. The point is 1, 1, 2. So you know that the graph is connected. So you know for it to have a 0, right? That's what the question is saying. For it to have a 0 or a root, it has to cross this x-axis. So it's impossible to go from this point to this point without it crossing the x-axis. So then you know it has a root. And that's the idea here before. You see how this means, you see, when I have f of 0 is less than 0, this is saying you have a point below the x-axis. What does this say? F of 1 is greater than 0. This is saying you have a point above the x-axis. Oh, sorry. I'll show it again. You see here it's saying if I have this point, f of 0, this is f of this point here. You see how one of the points is below the x-axis and one of the other points is above the x-axis. This is what it's saying. That's the notation. And I'm saying that if one is below the x-axis and one is above, there has to be a value of x, a value of c, where f of c is 0. And that's by the intermediate value theorem. Okie dokie. Let's take a look at the next question. Here, try and do it by yourself. Like, take your time. Like, you should only look at the video if you're really, really struggling. Okay? So let's take a look. what is the question saying? It's saying a car travels on a straight track during the interval from the time from 0 to 60 seconds. Okay, so this is the time, and the car's velocity is here. So notice this is like your x and your f of x. But instead of like x and f of x, you just have t and v of t. Okay, time and the velocity. So it's measured in feet per second. And notice over here, keyword, it's a continuous function. So here are the values. So in 0 seconds, the car's velocity was negative 20 feet per second. Okay, so here, let's see if we could use IVT. Let's check IVT. Because what the question is saying, it's saying within the time of 0 to 60, is there a value of t where v of t has to be negative 5? What I want you to do is pause the video and try and figure out where v of t has to be negative 5, between which times, like between which interval. Okay? If you want to see the solution, it has to be between 35 and 50 seconds, because isn't negative 5 in between negative 10 and 0, right? So you know between 35 seconds that the car's velocity has to be negative 5 feet per second, because you know the function's continuous. So it has to hit, because if you're at negative 10, for you to go to 0, you have to hit negative 5 before that. So let's use IVT to figure this out. So the first one, the function is continuous. Function is continuous because it's given. Okay? Let's see part 2. You know that this is our A and this is our B. So let's see, from 0 to 60. What is v of 0? V of 0, according to this, if this is the x value, this is the f of x value, then it's just negative 20. What about the next one? 60, v of 60. This is equal to 10. Notice that v of 0 does not equal v of 60. And so this is true, and this is true. Now let's look at the next part over here, part 3. Is v of A less than v of C, which is less than v of B? Okay, here, this has to be true, because what is this equal to? V of A is v of 0, right? It's the first part. This is v of 60, right? And what is v of 0? It is negative 20. And what's this v of c value? I'm sorry, this should be a v of c or v of t. What is that v of t value? Notice that this is v of t. Notice that this is negative 5. And then what's v of 60? This is 10. Is this inequality true? Is this inequality true? So if you know that this inequality is true, which it is, because negative 5 is between negative 20 and 10, thus, by IVT, you see, like, if you just write this and say this is true, you're not fully justifying, okay? So to fully justify, we have to say, thus, by IVT, there exists a time t such that the velocity of the car is negative 5. And where does that happen? It has to happen between 35 and 50. Somewhere in between that. Okay. So we did example 3 and example 4. For the next part, homework number 10, what I want you to do is try and do these questions by yourself. I unfortunately don't have time to do all these questions with you. What we'll do is, tomorrow we will go over all these questions, but I want you to try your hardest to do these questions. They're not impossible, okay? Best of luck. I'll see you tomorrow.